Welcome to my channel, The Sake of Physics. Today I'm going to talk about scalars and vectors. So, what is a scalar quantity? It's completely specified by its magnitude with appropriate units, for example, temperature, mass, time interval, and number of pages. It's manipulated using the rules of ordinary arithmetic. If two or more scalars are there, and if they have same units, for example, it would be meaningless to add temperature and volume. So we need to know that where we can add two scalar quantities when they have same units. What are vector quantities and how they are different from scalars? So they are also completely specified by its magnitude with appropriate units, but for vector we need direction too. For example, displacement, velocity, acceleration, and weight. So we need to use special procedures to manipulate the vectors. So we cannot add them up just simply using the arithmetic procedure. So there are different properties of vectors. Whenever we need to write a vector, either we can write it with a bold letter. For example, there is a vector A. So either we can write it up with the bold letter A or arrow on A, but its magnitude is simple A without any arrow. So there are vectors which we can say equal vectors when they have same magnitude and direction. So here you can see there are two vectors A and B. They are equal vectors because they have same length and same direction. Two or more vectors can be added if they have same units. So if A and B have same units, either they are velocities or displacements or weights, then we can simply add them up. So there is graphical method for adding vectors. So for example, if there is a vector A, any vector A, and another vector is given B in this direction, for example. So we can add them up using a head to tail rule. What does that mean? So for example, if I draw A and when I draw B, I need to use the same direction and same magnitude of B. Then the resultant vector or the vector after adding them will be, for example, R. So here we need to follow the head to tail rule. In this case, the tail of R and A, they are coinciding, and the last vector B head and the resultant head, they should be in the same direction. So here I can write down R equals A plus B. So the order doesn't matter. I can plot B first and then A, but I need to follow head to tail rule so that the resultant will be in this direction. So negative of a vector. So I can say that the vector that when added to a vector A gives 0 for the vector sum. What does that mean? So if a vector A is given and if I add negative of A, then I get a null vector actually. Basically, this is also a vector. But negative A is a negative of vector A. So if A is in this direction, for example, then negative of A will be in opposite direction with the same magnitude. How can we subtract vectors? So for example, I am given a vector A and I need to subtract a vector B. So for example, A is given in this direction and for example B is given in this direction, then negative of B will be like this. So if I need to add them up, then what I will draw negative of b like this. So this will be the resultant vector, which is equal to a minus b. So this is the graphical method. How can we draw vectors? So we can also multiply or divide a vector by a scalar. It means by a number. So for example, there is a vector a in this direction. If I multiply it with 3, then what does it mean? It will become 3 times a. And if I divide it by half, then for example, a vector b is given, and if I divide it by 2, then it will become half of b. So what is a unit vector? A vector with magnitude 1 in that direction. It is basically used to represent the direction of a vector. A unit vector in the direction of A is written as, so it comes up with the hat on it. So it's vector over its magnitude. So basically, whenever we represent a vector, it is equal to its magnitude and its direction. So here we can figure that out, that what is the unit vector in terms of magnitude and vector itself. So usually we use I, j and k for x, y and z axis. So for example, if I plot here x axis, so not only 2 dimensions, if I draw here 3 dimensions, then I, j and k are the unit vectors for x, y and z respectively. So as I already mentioned, null vector is a vector with zero magnitude and arbitrary direction. For example, the sum of a vector and its negative vector is a null vector. Thank you so much.